Hi everyone. Today we are going to discuss miscellaneous problem number 4 on successive differentiation. You know that what is the successive differentiation, guys? When you think about the successive differentiation, you know clearly if you are to given y is a function of x, then how to successive differentiate this y? We have to take first derivative of y, that is dy divided by dx. Again we have to take second derivative of y, that is we get d2y divided by dx square. Again we take d2y by dx square, it's a derivative, it will get d cube y divided by dx cube, and so on. We take nth order derivative, means dny upon dx raised to n. So this is called as, this is a differentiation of y with respect to x. What is that here? N times. But how to take this differentiation? We guys get successively get this differentiation. I hope you have to understand this. Now let me start miscellaneous problem number 4 on successive differentiation, guys. So I am taking the problem number 4 as, if y is equal to, that is a tan inverse of x by a, that means tan inverse of x divided by a, prove that yn is equal to, it is a minus 1 raised to n into n minus 1 factorial divided by a raised to n into sine n theta sine raised to n theta, sine n theta into sine raised to n theta, sine raised to n theta, where theta is given to you. Theta is nothing but here, that is a tan inverse of a by x, tan inverse of here a by x, a divided by x, because the tan inverse of x by a is y, so theta is tan inverse of a by x. So we have to solve this problem, guys. We have to solve this problem. So let me start. What is a solution? What is a solution, guys? Let's see. Let, given you know that I am writing here, let y is equal to, here clearly you will have to getting here tan inverse of x by a, tan inverse of x divided by a. We have to observe this. We have to getting the y is a tan inverse of x by a. So for references we call that is equation number 1. So differentiating with respect to x, we get, differentiating with respect to x, here we get, here it's a first order derivative as y1, and y1 is nothing but here 1 upon 1 plus tan inverse x by a derivative is 1 upon 1 plus, that is x square upon a square, into 1 divided by a is there, into 1 divided by a, that is the derivative of x by a is 1 divided by a. Again I am simplifying this, so what will you have to getting here? So that is a y1 is equal to, this will becomes a upon taking LCM of denominator, that is a square plus x square, and 1a is get cancelled, so here is a square plus x square. After that you have to also this taking the denominator is in the form of it's a factor, guys. So a upon, what are the factors of a square plus x square? So this is nothing but this is x plus I into a, in second bracket x minus I into a, that is nothing but it is an expansion of a square minus b square, likewise. So x plus ia, x minus ia. So again we have to simplifying this. So after that simplifying, this will becomes 2i, this will becomes 2i, that is x plus ia minus here x minus ia, total divided by here x plus ia into x minus ia. I am adjusting denominator term in numerator. I am adjusting denominator term in numerator. So clearly what we'll have to getting here again y. So clearly y we have to getting here. So y equals to, that is 1 upon 2i in bracket, that is 1 upon here x minus a, means x minus ia minus 1 upon x plus ia by using the partial fraction. So I am writing here since partial fraction, guys. So after the using the partial fraction, you will have to getting y1 now in this. So you have to carefully observe here, y1 is equal to 1 upon 2i in bracket x minus ia minus 1 upon x plus ia. Now let's see what we do here. So let y1 as, this is nothing but this is a 1 upon 2i, right? 1 upon 2i in bracket, that is 1 upon x minus a minus 1 upon x plus I into a. So differentiating this n minus 1 times, guys, because we already differentiate first. So differentiating n minus 1 times with respect to x, successively. So after taking differentiation of n minus 1 times, so that will get y1 and its n minus 1th derivative, it will becomes yn, and yn is equal to, that is minus 1 raised to, here n minus 1th time differentiation means n minus 1 into n minus 1 here factorial divided by here 2i, means in denominator there is a 2i, in bracket what is that here, 1 upon x minus ia bracket raised to n minus 1 upon x plus ia bracket raised to n. So you know, guys, it is very well, this is minus 1 raised to n minus 1 into n minus 1 factorial, and a raised to 1 means 1 raised to n, that is as it is. Now this is common term, and that is formula for n order derivative. Here n is replaced by only n minus 1, n is replaced by only n minus 1. So that's why we are to getting its nth order derivative. So for references we call that is equation number 2nd. Now I am suppose the terms as, so let x plus ia, that is a complex number is there, x plus ia is in the form of Euler's formula, that is r into e to the power I theta, and x minus ia, it can be given as r into e to the power minus I theta. Because of that, these are the complex number, and complex number in Euler's formula now e to the power I theta. So therefore here r is equal to, that is under root of here x square plus a square simply, and theta is equal to here tan inverse of here simply x by a, tan inverse of x by a. I hope you have to understand this. If your complex number is x plus iy, then r is under root x square plus y square, and theta is tan inverse of x divided by a. So this is what argument and amplitude of this complex number, and r is called as modulus of a complex number. So that implies, what is a tan theta? So tan theta is nothing but it is x upon a, means I have to write here, if theta is a tan inverse of a by x, so I am writing this, theta is a tan inverse of y by a. So there is little bit here change is there, y divided by a means here a divided by x. So here a divided by x, and therefore tan theta is remaining is, what is that, a divided by x. So that x is equal to here a cot theta, so that x is equal to a cot theta, where again I am writing r as, resubstitute the values of x is a square cot square theta, means x is nothing but your a cot theta, therefore x square is a square cot square theta plus a square. I hope you have to understand this. And this is what, taking a square as a common, so a square as a common, in bracket what is remaining is there, that is cot square theta plus 1. So therefore this can be written as this is a cosec theta. Taking square root on both sides, that will get a cosec theta. So r is equal to, therefore r is equal to here a cosec theta is there. Means you have to just little bit substitution is there. So substitution is, what is that here? We have to use this substitution, guys. We have to use this type of substitution in equation 2. So therefore equation 2 becomes, therefore equation 2 becomes, after taking this equation 2 becomes, so what will get 2 as yn, and yn is equal to, there is a minus 1 raised to n minus 1 factorial upon 2i, n minus 1 factorial upon 2i in bracket 1 upon r into e to the power minus I theta, r into e to the power minus I theta, this total bracket raised to n. Because of that, x minus ia, this can be written as r into e to the power minus I theta bracket raised to n, minus 1 upon here r into e to the power I theta and bracket power here again n. So this, guys, this bracket is completed here, and you will have to getting here in the next step. I have to write here. So therefore here yn can be written as here minus 1 raised to n minus 1 into n minus 1 factorial, this term as it is, divided by here 2i into 1 upon r raised to n, and this bracket can be written as it is e to the power I theta, means n power is there, so I am writing directly here e to the power I n theta, because by using de Moivre's theorem you have to write now in this way. Let's see the bracket is what. By using de Moivre's theorem, this is n multiplied by angle theta is there, so you will have to getting here e to the power here I n theta minus e to the power minus I n theta is there. So you will have to getting this yn now in this way. So therefore that yn is equal to here minus 1 raised to n. I am again simplifying this n minus 1 into n minus 1 factorial divided by here 2i, right, into that in theta minus in theta e to the power in theta, that is becomes by using hypotenuse or by using hyperbolic functions definition. So this can be written as this is 2i, I am adjusting 2i is there. So let's see. So it is 2i taking extra and r raised to n, and here e to the power in theta minus e to the power minus in theta divided by here I am taking 2i. So there is a little bit adjustment is there, so there adjust 2i. So therefore yn becomes, that is a minus 1 raised to n into n minus 1 factorial divided by here 2i. So that 2i upon r raised to n as it is, 2i upon r raised to n as it is, and this is a definition of sine of n theta. This is a definition of sine of n theta. Since what is the reason here? Since e to the power I theta minus e to the power minus I theta divided by here 2i, this is formula for sine of theta, sine of theta. So therefore here n is there, so I am writing here sine of n theta, sine of n theta. I hope you have to understanding up to this. So therefore this is equal to that 2i and 2i get becomes cancel is here. So therefore here is only minus 1 raised to n into n minus 1 factorial is there, into what will the remaining here, sine n theta upon r raised to n, sine n theta upon r raised to n. So therefore again you have to simplifying minus 1 raised to n into n minus 1 factorial. What is the sine n theta? Means upon a raised to n, means I am writing here sine n theta as it is divided by r raised to n can be written as this is what is the value of r? R is value that is a cosec theta, means r raised to n means a raised to n cosec raised to n, that is a theta. Since what is the reason I am taking the r as a cosec theta. And therefore minus 1 raised to n into n minus 1 factorial sine of n theta into, so a raised to n I am taking here for simplification, and here sine n theta into cosec upon cosec n theta. This can be written as, this is a sine of, so I am writing now this in this way, this is sine of n theta into sine raised to minus n theta. Why this is a minus n? So minus is not there, because of that only you have to observe 1 upon cosec means here again sine, 1 upon cosec x means again sine. So that's why I'm writing here sine of n power n theta, and I hope you that is your answer. So therefore yn is equal to here minus 1 raised to n up into n minus 1 factorial divided by here a raised to n into sine n theta into sine power n theta into sine power n theta. So this is called as where theta is tan inverse of, guys, a divided by x, and hence proof. I hope you have to understand this very well. So what is nth order derivative of the given function? If y is given to you tan inverse of x by a, then it is nth order derivative, hence we have to prove. I hope you have to understand and enjoy this problem very well. Thank you.